Now I'm going to use matrix multiplication to help me solve a system of equations. So if you have a system of equations where all the x's are lined up, the y's are lined up, if you have other variables, all the variables are lined up in columns and then equal to the constants on the other side, you can set this up in the form of a matrix. In the first matrix, I will put all the coefficients of the variables, so -5, 7, 4, -4. In the second matrix, x, y, and in the third matrix, the constants. Now to show you that this is actually the same as what we just had, if I do matrix multiplication, notice I do -5, 4 times xy. So that would be -5x plus 4y. -5x plus 4y. And then -7 -4 times xy would give me 7x minus 4y. And then since these two matrices multiplied together are equal to this matrix, then this is just 11, 2. So this is equal to 11, this is equal to 2. So that's how the setting up the system of the matrix system works. Now if I want to solve a matrix multiplication, let's just look in general form. If I call this matrix A, so here's matrix A right here, and this is matrix X, and this is matrix B. So I have matrix A times matrix X equals matrix B. What I want to do is get X by itself and figure out what that is. So it turns out if I multiply matrix A by its inverse, and this is the notation for an inverse matrix, and then do the same thing to the other side. And notice this is very important that it has to be done on the left-hand side, because I can multiply a 2 by 2 times a 2 by 1, but I can't multiply a 2 by 1 times a 2 by 2 because the inner dimensions don't match. So this has to be the 2 by 2 on the left, and this is the 1 by 2 over here. When I multiply a matrix by its inverse, I get the identity matrix. So I would just get 1, 0, 0, 1 here times my matrix xy, and then over here I would have these two matrices multiplied together. Well, if you do 1 times x plus 0 times y and 0 times x plus 1 times y, this just ends up being xy. So it turns out then that if I multiply the inverse of matrix A times matrix B, I'll figure out what x and y are. So let's look at how this is done on a calculator. First of all, let's set up a matrix equation. The first one is not set up nicely. I have to get everything in columns first. So I need to add 3x to both sides. So I have 3x plus 2y equals 1, and then 8x plus 7y equals -4. And now I can set up my matrix equation. 3, 2, 8, 7, xy equals 1, -4. Now to solve that then, xy is equal to the inverse matrix of 3, 2, 8, 7 times the matrix 1, -4. There is a way to do this by hand to find the inverse matrix for a 2 by 2. Actually, you can find any size matrix by hand, although they get more complicated with the larger sizes. But the point here is to use technology and the effectiveness of matrices with technology. So we're going to do this one on the calculator. So on your calculator, you'll find right here on this button, you'll see a matrix. You can see there's a 2 by 2 matrix, there's a 1 by 2, there's a 2 by 1, 1 by 2, yeah, 2 by 1, and then this matrix can be any size dimension. So right now I need this one. So I fill in those numbers that I have on my sheet, and of course I'm going to have to look. 3, 2, 8, 7. So 3, you can use a tab button to get from space to space. Now I need the inverse of this matrix, so I'm going to do caret and then -1. Okay. So just like the same symbol that we use for inverse function is used for an inverse matrix. And then multiply, and then I'm going to use a 2 by 1 matrix and going back and look at the numbers, that's going to be 1 and negative 4. So 1, negative 4. And then I just push enter. And that's my x and y. So x is 3 and y is negative 4. Now setting up another one. This is let's do number 2. I'm not going to do all of these on the calculator. To set up this one, notice the x's, the y's, and the z's are all in columns. So for number 2, we have 5, 3, negative 7, 10, negative 4, 6, 15, 1. Notice there is no coefficient in front of y, so it's just 1. Negative 8 times x, y, z in this case is equal to 3, 5, negative 2. So to solve this matrix equation, I'm going to have x, y, z is equal to this matrix 5, 3, negative 7, 10, negative 4, 6, 15, 1, negative 8, inverse matrix times 3, 5, negative 2. Putting that on my calculator, then I'll figure out what x, y, and z is. So I'm going to show you one more on the calculator so you'll know what to do with a larger matrix. So to do the larger matrix, I'm going to go to this matrix right here. Now notice when I click on that, it doesn't automatically just put a 3 by 3 because this one I can use to make any number of rows and columns I want. I happen to want a 3 by 3, so I'll put OK here. And let me fill in the numbers quickly. So I'm going to have to go back and look. 5, 3, negative 7, 10, negative 4, 6, 15, 1, negative 8. And then remember to the negative 1 power, because we need the inverse matrix here. And then we have times. Now we go to this matrix. Now I want a 1 by 3 matrix. I want 3 rows but 1 column. So now I have the size matrix I need there. I look at 3, 5, negative 2 are the numbers I need. 3, 5, negative 2, push enter. Now notice my answer came out in fractions, 61/50, 69/10, 17/5, which is a perfectly good way to tell you what x and y are. But if you go, if you select this and do Control Enter, then you'll get the decimal answers. Okay, so that's just like you do with any kind of computation. Let's just look at setting up a couple more of these. This one, what you'd end up for number 3, what you'd end up putting up in your calculator, you'd end up with x, or w, x, y, z. W would actually come first. W, x, y, z is equal to, and I would have I would be taking the inverse of this matrix. 1, 3, 4, negative 2 would be my first column. Negative 5, 1, negative 2, 3. My third column, 2, negative 3, 1, negative 1. My fourth column would be negative 1, 2, negative 1, 4. And that would be the inverse of that times negative 18, 17, negative 1, 11. Let me just point out that negative signs trip people up more often, or just miscopying numbers, so just be careful copying the numbers. Set up your matrix, actually write it out by hand, double check and make sure all the numbers match, and then that would go in your calculator. On my calculator I would do the same thing as I did as for the 3 by 3 one, only I would obviously have to change the dimensions to 4 by 4 and to 4 by 1. 4 rows and 1 column. Okay, last one. Just wanted to show you the setup for this one because it has some missing terms. Notice there's an x and a y, an x and a z, and a y and a z. So what I want to do is set this up as 5x minus 6y plus 0z equals negative 2. 5x plus 0y plus z equals 7, and 0x plus 2y minus z equals 4. So when you set your matrix up, it's a 3 by 3 matrix with the numbers 5, negative 6, 0, 5, 0, 1, and 0, 2, negative 1 in your matrix. I am going to let you do 3 and 4 on the calculator yourself, and I will just do them, pause the video, and find the answers so that you can check and make sure you're doing the calculator part right. Also, if you look at the printed notes online, there are very detailed instructions about the calculator part on the next page of the notes. Here's the answer to example number 3 and number 4 in both decimal form, or fraction form, and decimal form. You can see how they're set up. The last little question here says, how do you know if your answer is correct when you solve a system of equations? Well, hopefully you realize that you can take your numbers 2, 3, negative 2, and 1, plug those in for w, x, y, and z, and they should make every single equation true. If they don't make every equation true, then that is not the solution of the system.